Have you ever wondered how AI can make entire buildings, campuses, or even cities more energy efficient? That's exactly what the AI-based Energy Consumption Optimiser does. It's a predictive analytics system that learns energy usage patterns, correlates them with weather and occupancy data, and then recommends the best ways to reduce waste while keeping comfort intact. Think of it as a digital energy manager that never sleeps, continuously monitoring, forecasting, and optimizing. For example, it can predict tomorrow's air conditioning demand based on temperature and office attendance, then schedule systems smartly to save energy. This project is not only technically fascinating but also crucial for sustainability. As global energy prices rise and businesses commit to carbon neutrality, AI-driven optimization is becoming a must-have solution. For AI students and data professionals, this is a perfect capstone project that blends data science, machine learning, and environmental impact. A project that proves your AI skills can literally power a greener planet. Now let's look at how this technology is transforming real-world industries. In manufacturing plants, AI energy optimizers help reduce power consumption by 15 to 30% using smart load balancing and equipment scheduling. In commercial buildings like offices and malls, AI models adjust HHV, lighting, and elevators dynamically based on occupancy and weather. And in smart cities, municipal buildings use similar systems to cut costs while meeting sustainability goals. Why does this matter? Because energy prices are climbing while environmental mandates are getting stricter. Companies now face dual pressure: reduce carbon and reduce costs, and AI offers a clear, measurable way to do both. Businesses report 10 to 25% savings, often with full return on investment in just over a year. That's massive. This is why hiring is exploding in sectors like smart building technology, facility management, and industrial IoT. For you, as an AI engineer, this means opportunities that are not just profitable, they're planet positive. To build an AI system that predicts and optimizes energy use, you need to master a strong technical foundation. The core of this project is time series forecasting, using models like ARIMA, Profit, and LSTM networks to analyze historical data and predict future demand. You'll complement this with regression models like XGBoost and Random Forest to handle nonlinear trends. Python is your main toolkit, with libraries such as Pandas, Scikit-learn, Stats models, and TensorFlow doing the heavy lifting. You'll process sensor data from IoT devices, handle missing values, and create features from weather data, occupancy rates, and equipment schedules. For deployment, tools like Azure IoT Hub, AWS IoT Core, InfluxDB, Grafana, and Kafka help you stream, store, and visualize energy data in real time. Domain knowledge is equally vital. Understanding building management systems, tariff structures, and sustainability standards gives your model real-world relevance. This combination of technical and domain expertise is exactly what recruiters look for in AI energy analysts today. Let's break down how to build the AI-based Energy Consumption Optimiser step by step. Start with data acquisition. Use open datasets like UKDale or RED, or simulate your own building data with sensors and equipment logs. Include weather APIs and occupancy data to make your dataset realistic. Next, do exploratory analysis. Identify daily or weekly energy patterns, spot peak hours, and correlate consumption with temperature or holidays. Then, in the model development phase, train forecasting models for hourly or daily predictions using LSTM or Profit for clear seasonal trends. Once your predictions are reliable, build the optimization engine, a system that suggests actions like shifting loads to off-peak hours, scheduling maintenance, or flagging waste. Finally, create dashboards and alert systems in Grafana or Power BI to visualize usage, predicted savings, and carbon reduction. Beginners can complete this in 8 to 10 weeks, while intermediates can do it in 4 to 5. Each phase teaches you essential data science and deployment skills. So what career opportunities does this project unlock for you? A lot. Roles like energy data scientist, IoT analytics engineer, smart building AI specialist, and sustainability data analyst are rapidly growing across global companies. Recruiters love candidates who can demonstrate real-world forecasting projects, dashboard skills, and measurable energy savings, exactly what this project gives you. You'll gain practical experience in handling IoT data, optimizing systems, and building predictive maintenance models, all keywords that catch recruiter attention instantly. Companies like Schneider Electric, Siemens, Honeywell, and Johnson Controls are actively hiring for these skills, along with innovative startups in smart infrastructure. Entry to mid-level salaries range between 8 and 16 LPA in India, and between $85 to $155,000 internationally. This is the kind of portfolio project that positions you as a data-driven sustainability innovator. So if you're ready to prove that AI can help power a cleaner, smarter world, start building this today and put it on GitHub.